Okay, so this week we're looking at Venn diagrams. Now, you may have seen Venn diagrams before. In fact, you've definitely seen Venn diagrams before. They look like this. You have two circles. Which cross over like this. Okay, so this is what a Venn diagram looks like. And you would have seen them before when we looked at prime factors. The whole point of a Venn diagram is that this area in here means both. Okay, it means both circles together. Okay, and what we're going to do is I'm going to explain how we're going to use Venn diagrams for probability using an example. So I'm going to pretend that we've got a survey. So I've got 30 people in a survey. And I'm asking the question, do you own a dog or a cat? So, of those people, 20 own a cat, 16 own a dog, and 8 own both a cat and a dog. Okay, so 20 own a cat, 16 own a dog, and both own both. Sorry, 8 own both. So the fact it says 20 doesn't mean they only own a cat. It just means the question is, do you own a cat? Yes or no. If they said yes, they're in this 20. If they own a dog, they're in this 16. So what I'm going to do is I'm going to draw a Venn diagram to show this data. Make it nice and big. Whenever you do a Venn diagram, you don't need to worry about making it perfect, and having perfect circles. People waste a lot of time doing that, so don't worry about making it absolutely perfect. What I'm going to do is I'm going to call this circle on the left cats, this one dogs, and so the middle, hopefully you can see, represents both. Now this is where we're going to start drawing our diagram. We know that 8 people own a cat and a dog, so we're going to put them in here in the middle. Okay, a cat and a dog. So the question is, what goes here? How many people just own a dog? Only a dog. Well, you might be tempted to put 16 in there, but that wouldn't be right. Okay, so 16 people own a dog, but of those 16, 8 also own a cat. So the number left is 16 minus 8, and that goes here. Okay, so 8 people own just a dog. We do the same on the other side. 20 people own a cat, but of those 20, 8 of them also own a dog. Okay, so we take 8 away from 20 and we're left with 12. So if you were to sort of get some people and say, right, I'm going to draw this on the floor, you're only have to stand in one place. You obviously couldn't stand in cats and dogs unless you stood in the middle bit. Okay, so you can't be here and here. So it's not 20 in here for cats and it's not 16 for dogs. Okay, you've got to take off that both to see what's there. So the next question is, we've got 30 people. So how many people own neither? How many people don't own a cat or a dog? Well, we've got 30 in total. Let's see what we've got in the diagram so far. We've got 12 plus 8, which is 20, plus another 8 is 28. So we have 30 minus 28, which is 2. Now we've put this 2 outside the diagram. Okay, we put it outside to show that it's neither in dogs or cats or both. Okay, so I'm just going to label this up quickly just to show you. So this middle bit in here, go with cats. So that means you own a cat and a dog. In here it means you only own a dog. In here, you only own a cat. Okay, and here means you own neither a cat or a dog. Okay. Right, so I'm going to keep this diagram, but I'm just going to clear this page a little bit. Okay, so those numbers were 12, 8, 8, 2, and it was cats and dogs. Okay, so all the information we've got here is represented. Okay, 30 people in total, remember, and this Venn diagram is showing us the information about the pets they own. So if I was to ask you, right, what's the probability of one of these people owning both a cat and a dog? You can use this diagram to work it out. So find where it is on the diagram. Owning both a cat and a dog, that's 8. What's the total number of people? 30. So the answer is the probability of that is 8 over 30. Okay, I could say what's the probability of owning just a cat? Again, find it on the diagram. Just a cat would be 12 out of a total of 30, so that's 12 over 30. And finally, I could say, what's the probability of owning neither? Okay, so the probability of owning neither. Okay, neither would be 2 out of 30. Okay, so that's all good. We can just pick off values from the diagram. But I might ask you a slightly more complex question. I might say, what's the probability of owning a dog? Okay, so the probability of owning a dog. Now this might sound like the same question I just asked. So you might be thinking, right, well, that's just 8 out of 30. But think about it. Probability of owning a dog must be this one here, this 8, only owning a dog, but also owning a cat and a dog. Okay, so the probability of owning a dog would be both of these 8, so add them together, 16, 16 out of 30. Okay, if I was to say what's the probability of owning only a dog, that would be 8. But because I've said owning a dog, it's both of these. So you've got to be really, really careful when you look at these questions. Okay, so what I'm going to give you next is another Venn diagram, but I'm not going to give you all the information about it. I'm just going to say that I'm going to call this circle A and this circle B. So we've got A and B. I'm going to put the values in. So I'm going to say in this bit here, I have 7. In this bit here, between them, A and B, I have 5. Just in B, I have 3. And then outside the diagram, I have 10. Okay, so this is a diagram saying I've got A and B. Okay, so I might say, well, what's the probability of having A and B? Well, that would be 5 out of the total. Okay, so when you get a diagram like this, the first thing to think about is what's the total number of people? Okay, it may be what's your favourite fruit, apples or bananas? Okay, and someone said, I don't know, I want them both. But just consider it to be A and B for the moment. Now the total, we're going to add up all the digits here. So we have 7 plus 3 plus 5 plus 10. That gives me 15 plus 10, so 25. Okay, so the first thing to write, total equals 25. Okay, now if I want to know what the probability from this diagram is of choosing A and B, I might say probability of A and B. But this is quite a lot of writing, and I might want a better way of writing this. We know the answer that we're aiming for is 5. out of 25. But you probably won't be asked like this. You'll probably be asked this. What is P A B? Now this is a weird thing to write. It looks like a little n. It's actually not an n. It's called an intersection. Now what this means is, what's the probability of A and B being at the same time? So what's the probability of it being this 5 in between these two circles? The way I like to think about it is A and B, it's a bit like salt and pepper. I suppose that helps. But it's a bit like an N to stand for kind of and. So probability of A and B is this middle section here, the 5. Okay, I might also ask the question, okay, what's the probability of A? And the way I'd write this is I'd write P brackets A. Okay, so in this case, it's got to be everything in this circle. 7 plus 5, that's 12. So it's 12 out of 25. Okay, I could keep going. Let's have a think. P of B, think about it yourself. Well, it's got to be everything in this circle, so 5 plus 3. So that's 8 out of 25. Okay. Now, the last thing I might think about is, what would the probability of A or B be? Okay, so it could be A or B. Now, the way we write this, so I'll put probability of A or B, so it could be either. I write this like this. It's like an upside down N, like over here. And this means A union B, which basically means it can be anything in here. So the probability of it being A or B is going to be 7 plus 5 plus 3. So anything inside this circle. Okay? If you think back to the last example we looked at, it would be a bit like asking, do you own a cat or a dog? And if the answer to that is yes, then you'd be in these two circles. Okay? So in this case, what I'd do is I'd say A union B, it's 7 plus 5 plus 3, which is 15. Okay? That's just a bit of an introduction to what this sort of notation is here and what this is here. You can get more complicated than this, but I'm not going to. There's no need, but just remember what these things mean, okay? Okay, so let's look through some questions. Here's the first one. We have a list of numbers here, and we want to put into this Venn diagram. So hopefully quite an easy start. Multiples of 3 and odd numbers. So if we put them in the diagram, we can cross them off. So we've done the first two. Okay, so multiples of 3 and odd numbers. So we need to think about what's going to go in the middle of this chart. Well, in the middle, they must be odd and a multiple of 3. So let's look for some odd multiples of 3. So here's one, 27. That's odd and a multiple of 3. 15. 45. Any more? 33. Okay, I think, and 3 as well. 21 can go in there. And I think the rest, I think we're okay. So we want to look for just multiples of 3 which are even. Okay, so 30 can go in here. 12 can go in there, 24, 18, 6 goes in here, 36 and 300. Okay, so what we're left with is odd numbers. Okay, so 17 is an odd number. That's it. So we're left with 16 and 20. Well, where are these going to go? Well, because we've defined this circle as multiples of 3, this one was odd numbers, 16 is neither a multiple of 3 nor an odd number, so it must go outside the diagram. 20, is it a multiple of 3? No. Is it odd? No, so it must go outside. Okay, so let's just think quickly about what these regions mean on this question. In here, this is a multiple of 3 and odd. Okay, so multiple of 3 and odd. This region here is odd, but not a multiple of 3. In here is a multiple of 3, but not odd. And out here is even and not a multiple of 3. Okay, so here's another question about Venn diagrams. We have a class of 32 pupils. Oh, in red apparently, that's nice. Let's go back to black quickly, there we go. 23 have a brother, 14 have a brother and a sister, and 6 pupils have no brothers or sisters. Okay, so we want to work out what goes in each part of this Venn diagram. Okay, so we'll follow the lead that what they've done. They've put brother on the left-hand side and put sister on the right. Okay, so 14 pupils have a brother and a sister. Okay, so they can go in the middle. That should be your first port of call. 23 have a brother. Okay, so remember what we did before. We don't write 23 in here. We write 23 minus 14. Okay, so in here is 9. 9 people only have a brother. Do the same for the sister. So we have 32. Okay, we don't have information about the sisters, but we know 6 people have no brothers or sisters. Okay, so our diagram is just missing this bit. Now remember, it's 32 in total, so we do 9 plus 14 plus 6. Okay, that gives us 29, so the missing number is 3. Okay, so that's how you complete the Venn diagram. Always start in the middle if you've got that information, then you can work outwards. Okay, the final question to look at, we have a completed Venn diagram, and I want to know the following. So we want to know what the probability of R is. We want to know what the probability of R intersection Q. I want to know what the probability of R union Q. And let's go for the probability of not R, and finally the probability of not R or Q. Okay, so the first one, what's the probability of R? Well, what are all the what's the total in the circle R? Well, it's 5 plus 12. Okay, and that gives me a total of 17. 17 out of the total. Now the total is going to be 17 plus 1, so 18 plus 10. So the total number is 28. Okay, the probability of R intersection Q, remember this means this one here, just 12. So that's going to be 12 out of 28. R union Q is everything inside these circles. Okay, so that's 18 out of 28. This is something a little bit new. This dash means not R. So anything but this circle. So we ignore what's in this circle and we go outside it. So not in the circle, so that's 1 plus 10. So that's 11. Finally, not R or Q, so that means nothing inside here. So it's just 10. Okay, this one and this one, a bit more of an extension idea, so don't worry about those two, but these three need to know. Okay, good luck with the questions. Have a go.